So the last subatomic particle is known as a neutron. It has a mass of 1 atomic mass unit, a charge of 0. Its location is in the nucleus, and the short form is an N with a superscript charge of 0. Again, it was Ernest Rutherford who first determined that neutrons existed. This happened in 1920. What he did was he figured out what mass of protons it would take to balance the negative charge of the electrons in atoms of different elements. And then what he did was he compared his mass of those elements to the real atoms. And he noticed that in real life, those elements weighed significantly more than his calculations did. So he proposed that there had to be another particle in the nucleus that accounted for this extra mass in real life, and it was made up with particles that had the same mass as protons, but had a neutral charge. So that's why he called them neutrons. Later on in 1932, one of Rutherford's grad students, James Chadwick, actually conducted experiments and physically proved the existence of neutrons. Now let's go back and continue our discussion on electrons. So we left with the planetary model of the atom coming from Rutherford. So that was protons in the nucleus, hard, densely packed, and positive, and negative electrons that orbit around the nucleus like the planets go around the sun. But Rutherford noticed, using classical physics at the time, that his model wouldn't work. Because the nucleus is positive and electrons are negative, they would quickly spiral in because of the attraction and join on and not be orbiting the nucleus of the atom anymore. And that would basically cause the destruction of the atom. So using his model, he was concerned that it proved that atoms don't exist. There was no way for them to support themselves against this attractive charge difference. So one of Rutherford's students, named Niels Bohr, found a way to save Rutherford's model. And how he did it was by using the work of other physicists at the time, the first one being Max Planck. What he noticed was that matter absorbs and releases energy in only specific amounts. So let's say the specific amount is 5 kilojoules of energy. So an atom can absorb any increment of 5, so 5, 10, 15, 20, but nothing in between. Planck described these packets as quantum. At the same time, Albert Einstein was studying light, and he noticed that energy traveled as light in packets of energy that he later called photons. And so Bohr noticed that both of these physicists were dealing with energy traveling in specific amounts. So what Bohr proposed was that the kinetic energy of an electron can only be a specific amount. Bohr was also trying to explain a phenomenon known as atomic emission spectra, which no one was able to explain before. You guys probably remember the lab in grade 9 called the flame test, where you burn different chemicals and they produce different colors of light. So Bohr came up with 3 statements for his model. He said that electrons could only exist at certain energy levels, which he called stationary states. So you can have an electron here, an electron here, an electron here, but no value of kinetic energy in between. So stationary states are now called shells or orbits. And what he said was when an electron was in one of these orbits, that it did not gain or lose any energy. So that fixed Rutherford's problem of the electron spiraling in and towards the nucleus. Now, to explain the atomic emission spectrum, what he said was, in order to take an electron and move it to a higher level of energy, you had to heat it or give that electron a little bit of energy, and it needed a specific amount. Now, that would make the atom less stable. when the electron jumped back down to that original energy level, it had to release that amount of energy as well, but it released it in the form of light. And because there are different amounts of energy in between the different levels, you got different wavelengths of light, such as red and green and blue and purple coming off each atom, depending on where the electron starts and where it jumps to. That's also shown in this graph over here. So if you take a hydrogen atom and move an electron up to the third energy level, and then it jumps down to the second energy level, you get red light produced. If it goes from the fourth to the second, green, and so on. So Bohr did a bunch of calculations to figure out what wavelengths of light would be produced if you had electrons moving from different predictable energy levels. And he was very successfully at predicting these amounts of energy in these wavelengths of light. The only problem, though, was that his model was only accurate for atoms that had one electron. And so if you look on the periodic table, that's not the majority of elements that are out there. So it only works for hydrogen. It also works for helium if you take an electron away from it and make it a 1 plus. Lithium if you steal 2 electrons, or beryllium if you steal 3. So Bohr model isn't perfect, but think of all the chemistry that you've done over your high school career using Bohr model. It's a pretty good model. It explains how compounds form, it explains why they give off different light, and we balanced chemical equations and used stoichiometry and did all that stuff in grade 11 using this model.